The Asia-Pacific region stands at the nexus of a dual crisis: a massive urban waste generation challenge and an urgent demand for sustainable energy sources. Waste-to-energy (WTE) initiatives have emerged as a primary infrastructure solution, driven by rapid urbanization and aggressive government mandates to reduce landfill dependency. This video provides a deep dive into the APAC WTE landscape, addressing the strategic rationale, technological suitability for unique Asian municipal solid waste, or MSW, characteristics, market dynamics, and critical financial and policy support mechanisms. Explosive growth. APAC is the fastest-growing WTE market globally, projected to reach $35.44 billion by 2030, reflecting a high-risk, high-return environment. Technical constraint. The single greatest impediment to efficient WTE deployment in developing Asia is the high moisture content and low calorific value of commingled MSW, leading to operational inefficiencies and project failure. Financial reality. Project viability hinges on mitigating The fundamental impetus for WTE adoption across Asia is the untenable growth of urban waste volumes coupled with diminishing landfill space. Countries experiencing rapid urbanization, such as China, India, and Japan, are struggling to manage enormous quantities of municipal solid waste. For example, the volume of MSW generated in China was 244 million tons in 2022 and is expected to increase significantly, potentially reaching 332.4 million tons annually by 2025. While landfilling and open dumps remain the primary disposal choice in most developing Asian countries, this method is environmentally unsustainable and socially unacceptable in high-density urban areas. Governments are responding by introducing stricter waste management regulations and ambitious renewable energy targets specifically aimed at reducing reliance on landfills. WE facilities convert waste into electricity and heat, aligning directly with both waste reduction and renewable energy goals. These facilities are positioned as essential infrastructure solutions that provide a reliable renewable energy source, thereby reducing reliance on fossil fuels while simultaneously ensuring compliance with stringent environmental standards. This reliability is vital in regions like Vietnam, where power consumption is expected to grow between 10% and 12% annually through 2030. A critical distinction must be made regarding the primary objective of WTE facilities in developing Asian economies compared to developed counterparts. In high-volume environments like China, the chief goal of WTE plants is to alleviate the massive solid waste problem through volume reduction, with electricity generation serving as a welcome byproduct rather than a core mission. This priority shift has significant financial implications. Since the operational success is measured primarily by waste throughput rather than optimized electrical output, government funding mechanisms often must guarantee high tipping fees to the operator. This guarantee compensates for the higher operational expenditure, OPEX, and accelerated corrosion caused by processing low-quality, high-moisture waste. Without this guaranteed income stream, projects processing poor-quality feedstock risk financial distress, as evidenced by case studies in India. Therefore, the social return derived from land saving and public health improvement justifies the expense, ensuring project bankability even when the energy recovery efficiency is suboptimal. The feasibility of WTE in Asia is fundamentally constrained by the physical characteristics of the municipal solid waste stream, necessitating tailored technological adaptation. The composition of MSW in much of developing Asia presents the greatest barrier to efficient WTE operations. Waste in these regions is characterized by a high proportion of organic material, often 45% to 50% kitchen waste. When collected commingled, this results in significantly high moisture content, reported to be between 52% and 66% in some Malaysian cities. This high moisture content is problematic because it drastically reduces the waste's net calorific value, LCV, impeding efficient combustion and leading to poor ignition. While some South Asian countries report average LCVs ranging from 1411 to 2150 kcal, kg, actual operational waste supplied to facilities can be far lower. A failed project in India, for instance, received waste with an LCV of only 600 to 700 kcal/kg, significantly below the required minimum, forcing the plant to shut down despite attempts to supplement combustion with diesel. Furthermore, the higher temperatures required to combust high-moisture, organic-rich waste accelerate the corrosion rate of incinerator components, leading to increased maintenance costs and reduced asset life. While the global WT market remains dominated by the thermal segment, which accounts for 81.7% of the revenue share, the unique characteristics of Asian MSW demand consideration of alternative or advanced thermal solutions. First way is mass burn incineration. This is the most common technology, but its electrical efficiency is typically maximized at only 27%. For low LCV waste, mass burn facilities often struggle to maintain self-sustaining combustion without substantial pretreatment, such as bio-drying or solar drying, to reduce moisture content. The second way is advanced thermal treatment, gasification and pyrolysis, which convert carbon-based materials into primarily gaseous outputs. SINGAs offer marginally better theoretical efficiency, potentially reaching 30%. Recent innovations in gasification processes, which convert solid waste into SINGAs, have enhanced efficiency and are seen as contributing to market growth. Another way is plasma treatment. This highly advanced thermal method has demonstrated superior electrical efficiency, achieving 33.5% even when processing MSW with high moisture content, up to 70%, making it technically compelling for the challenging Asian feedstock profile. We can also look at biological treatment. The biological segment, including anaerobic digestion, is projected to witness the fastest compound annual growth rate, CAGR, globally at 9.3%. Given the high organic fraction of Asian waste, deploying biological processes upstream for organic waste diversion can simultaneously produce biogas and significantly improve the LCV of the residual waste stream, intended for thermal recovery. The prevailing global technology preference for mass burn thermal WT creates a technical mismatch when deployed in Southeast Asia due to the low calorific value of the waste. This results in WT projects that operate below optimal efficiency, relying heavily on policy mechanisms rather than high energy recovery sales for financial viability. To overcome this inherent technological constraint, countries like Japan mandate robust source segregation, enabling WT to contribute to over 75% of solid waste treatment. Absent mandatory and effective segregation, sustained profitability requires either significant investment in advanced technologies, e.g., plasma, or compensatory financial policies, such as elevated tipping fees, to ensure operational continuity despite the low-quality fuel. The Asia-Pacific WD market was valued at $10.39 billion in 2023 and is projected to skyrocket to $35.44 billion by 2030, representing a phenomenal compound annual growth rate, CAGR, of 19.5%. This growth is driven largely by massive infrastructure deployment in key markets. China's centralized planning and investment have resulted in an enormous scale, with the country's total incineration capacity growing to approximately 1.17 million tons per day by 2024. The Southeast Asia market, while smaller, is also growing rapidly. The SEA WT market size was estimated at $3.68 billion in 2024 and is expected to reach $7.70 billion by 2030, growing at a robust CAGR of 12.79%. The WT development landscape is stratified, with established high-technology leaders competing with state-backed regional exporters. Major developers and operators include Japanese firms like JFE Engineering Corporation and Kawasaki Heavy Industries, and Keppel Seghers, headquartered in Singapore. These firms have been involved in major regional projects such as the Hong Kong Integrated Waste Management Facility, HKIWMF, and the Singapore Integrated Waste Management Facility, IWMF. Crucially, the market has seen aggressive outward expansion by Chinese enterprises. As China's domestic WT market approaches saturation, companies have focused on international markets, particularly Central Asia, South Asia, and Southeast Asia. As of mid-2025, Chinese entities were invested in, constructed, or operating 43 overseas WT projects with a total design treatment capacity of 57,700 tons per day. Vietnam and Thailand host the largest numbers of these projects, indicating a strategic focus on burgeoning Southeast Asian economies. The state-led rapid WT deployment model, particularly evident in China, has accelerated the build-out of infrastructure but introduces a systemic hazard: the risk of overcapacity. When incineration capacity exceeds the available waste stream, municipalities become incentivized to prioritize feeding the massive plants to meet volume quotas. This over-reliance on incineration capacity can actively disincentivize necessary upstream behavior changes, such as recycling and composting programs. The circular economy paradigm advocates for designing waste out of the system entirely, yet excessive investment in WT infrastructure risks creating a structural barrier against effective resource recovery. This highlights the need for governments, like Singapore, to implement comprehensive circular economy models that integrate WT as a complement to, rather than a competitor for, material recovery. The high level of perceived and actual risk in developing Asian markets translates directly into higher financing costs. The cost of capital, measured by the weighted average cost of capital, WACC, is significantly higher in Southeast Asia than in advanced economies, 5.0 to 6.5%. The median WACC, nominal post-tax, for low-emissions power projects in 2024 was 9.4% in Indonesia, 9% in Vietnam, and 8% in the Philippines. These elevated rates reflect inherent risks, including policy inconsistency, inadequate grid infrastructure, and exposure to fluctuating global interest rates on USD-denominated loans. This high WACC necessitates high returns for private equity investors. While typical solar projects in Vietnam target 6.1% IRR, the Philippines targets 11% to 16%. However, specific WT incineration projects in Indonesian cities have reported extraordinarily high average IRRs, such as 56.14% in Surabaya and 45.9% in Serang. These high local IRRs suggest that, where municipal risk guarantees are exceptionally strong, private developers demand a substantial financial premium to justify their investment in high-risk environments. Additionally, WT projects can leverage carbon credits to bolster financial viability. Asia is a major hub for voluntary carbon credit issuance, VCS, and gold standard. Schemes like Japan's Joint Crediting Mechanism, JCM, further support climate projects, providing a crucial non-energy revenue source that improves the overall economics of WT facilities. The significant difference between the median WACC of 9.4% in Indonesia and the reported localized WT project IRR of up to 56% illustrates a crucial economic reality. WT bankability in developing Asia is a function of successful risk externalization rather than inherent cost efficiency. Where the public sector, typically the municipality, offers robust guarantees, such as high, guaranteed tipping fees and the take-or-pay commitment, the private sector is willing to deploy capital but demands a commensurately high return to compensate for the fundamental uncertainties reflected in the high WACC. If these public guarantees are weak or regulatory support is inconsistent, even theoretically profitable projects face shutdown, as demonstrated by the technical failure of an Indian WT plant due to unreliable waste quality. Operational sustainability in Asia hinges on meeting environmental standards, particularly regarding combustion byproducts and navigating complex sociopolitical resistance. While WT incineration significantly reduces waste volume, it produces substantial residue. Approximately 20% of the treated waste mass becomes bottom ash, and 3% to 4% becomes fly ash. Bottom ash recycling. Bottom ash is often reusable. In countries like Taiwan, Bottom ash is processed into incineration recycled aggregate for road-based construction, supported by policies promoting its safe application. Japan also utilizes bottom ash as a minor raw material substitute for cement production, though use is limited by chlorine content. Fly ash as hazardous waste. Fly ash presents a far greater challenge, as it is classified as hazardous waste in the PRC and requires stabilization treatment to reduce hazardous components before final disposal in landfills. Sustainable use and final disposal of fly ash remain a persistent challenge in the PRC, necessitating the development of new technical guidance and regulatory frameworks, potentially mirroring standards in Japan or Germany. The cost implications are substantial, with fly ash prices in China reported around $16 to $27 per metric ton (MT) in 2025, compared to much higher prices in other global markets, reflecting regional differences in utilization and regulatory environment. Fly ash management costs are a significant component of WTE-OPEX. Emission compliance. Compliance with stringent emission standards is critical. Since 2014, China's incinerators have implemented dioxin emission standards on par with European levels, limited to $1 /text ing/$3 toxic equivalent. However, experts indicate that compliance gaps persist for other pollutants, specifically hydrochloric acid, sulfur dioxide, and nitrogen oxide standards. Furthermore, the identity of the facility operator introduces a geopolitical layer of risk. A study conducted in Thailand demonstrated that public support for WTE plants was significantly lower when operated by Chinese companies, a phenomenon termed the penalty for foreignness. Conversely, plants operated by Japanese firms did not experience this negative public reaction. This highlights that in the sensitive environmental infrastructure sector, foreign investment must be strategically managed, as geopolitical perceptions can create tangible social license risk and public resistance, adding complexity beyond standard financial and technical risk assessment. Singapore is recognized as a high-density, advanced urban economy that has successfully deployed WTE as a core component of its circular economy strategy, targeting net zero carbon emissions by mid-century. The Keppel Seghers plant serves as a model for private participation, demonstrating how high-quality risk guarantees can secure long-term finance. By adopting the DBO scheme with a full take-or-pay agreement, Singapore effectively shielded the operator from demand risk, ensuring continuous operation and bankability. The experience of early WTE projects in India underscores the fatal consequence of neglecting waste quality. A plant in Delhi, built by Valand Miljotechnik Limited, was forced to shut down after only 21 days of trial operations. The plant required a net calorific value of at least 1,462.5 kilocalories per kilogram, but the municipal solid waste supplied had an LCV of only 600 to 700 kcal/kg. This case exemplifies the critical need for a functioning waste pretreatment and segregation infrastructure to precede technological deployment, regardless of financing models or technology choice. The recommendations below include: mandate upstream waste quality control. Policy bodies must prioritize mandatory source segregation and pretreatment technologies, like biodrying, to raise the LCV of municipal feedstock. This stabilization step is essential for reducing long-term OPEX related to corrosion and ensuring technical resilience, thereby reducing the dependency on perpetually high subsidies. Institutionalize the DBO take-or-pay model. Developing economies should adopt robust public-private partnership models, specifically the DBO structure with government capacity guarantees, as pioneered by Singapore. This explicit absorption of demand risk by the public sector is the most effective policy mechanism to lower the weighted average cost of capital, WACC, and mobilize long-term private infrastructure finance. Integrate residue management and circular economy targets. Policy frameworks must standardize hazardous fly ash stabilization and promote bottom ash recycling guidelines based on best practices from Japan and Germany. Simultaneously, WTE deployment targets must be explicitly balanced with source reduction goals to prevent structural overcapacity from undermining national circular economy objectives. The Asia-Pacific WT market offers a compelling investment proposition, characterized by strong governmental support and explosive growth driven by dual pressures, massive waste volumes, and escalating energy demand. However, the sector is defined by unique operational and financial risks rooted in the low quality of the municipal feedstock and the political environment. We can draw the conclusion here. Risk mitigation determines viability. Project financial viability is primarily secured not through optimized electricity sales, but through robust municipal risk transfer mechanisms, e.g., take-or-pay contracts and high tipping fees, that guarantee minimum returns and compensate for the technical inefficiencies and increased OPEX resulting from low LCV waste. The LCV gap is the primary technical risk. The high moisture content and low calorific value of developing Asian MSW presents a fundamental technical challenge that necessitates either mandatory upstream segregation, Japan model, or investment in expensive, highly efficient thermal processes, e.g., plasma treatment. Failure to address this pre-combustion constraint leads to guaranteed project failure, India model. Geopolitical risk is financial risk. The proliferation of overseas WT projects by regional competitors introduces social license hazards. Public perception, influenced by geopolitical factors, can translate into measurable opposition risk for foreign operators, demanding careful management of local partnerships and corporate transparency.